Okay, so I'm Merryn. I work in maths support at Western Sydney Uni, and this project actually came into existence because of FYiMaths. When I first started coming, there was a lot of discussion about terrible management decisions that were doing bad things to maths teaching. I think at the time it was about assessment and unis trying to make decrees that you couldn't do exams in maths at all. And there was lots of discussion and lots of ideas about what to do about this. And I was sort of thinking, well, is there any way I can contribute? Or, so I went and had a look at the literature about this. I was thinking, well, why would anyone think that exams are evil and should be abandoned? So I had a look in the literature, the non-maths literature, to see what was going on. And what I did find in there was that there were quite a number of papers that were highly disparaging about mathematicians. And these papers sort of went along the lines, everybody's moved on from exams because they're evil, except mathematicians. And they insist on doing them because they're such dinosaurs they can't get with the times. And then people cited this person saying that. And there's this whole strain of this stuff. And I was thinking, well, that's rubbish. But there wasn't any papers out there that said, that's rubbish and here's why. So I was thinking, well, maybe there's a case for collecting the mathematical voice and actually responding to some of these claims that are being made by people who didn't bother to talk to mathematicians before they made them, and they're just getting propagated. So that's where it started. So this is the current project team. Your first activity is to try and figure out which face matches which name, but that's us at the present time. It's slowly growing, and it's really good. I've been told now that I've joined the dream team, now that Anthony and Gazama have joined us. So there's three basic questions that we're asking in a subject-specific context. So given a particular cohort of students in a particular subject, what should the student be gaining? So what should they be learning? What should they be getting out of doing the subject? And, what's the point of them doing the subject at all? From that, how should they be taught in this subject, and how should they be assessed in the subject? And we're interested, I guess there's two projects wrapped into one. We're interested in the student voice on this. What do students think about all of this? And I'll tell you a little bit more about that later. And also, what do educators think about this? Very broad interpretation of what we mean by educator. Really, we're interested in anyone who's involved in teaching maths or statistics or maths support at a uni level, who's actively interested in the education. So it's not a random selection of people. We're interested in people who think about and care about these topics and what their thoughts are. Why do this? So like I said at the start, one reason, the initial reason, was to present maths educators' voices to the debates on learning and teaching the non-maths culture. Sorry, non-maths literature, but the project's actually grown into something that's much bigger than that. There's a lot of people have been interested, and through our interviews, what we're capturing is, first of all, an information exchange portal. So a lot of people are saying, well, I'm in this context, I've met these problems, this is what I've done, and this is the outcome. So we're getting a whole collection of scenarios and what works and doesn't work for different people in those scenarios that we can, put together and share. We're ending up with a living history snapshot of what maths and stats educators think at this point in time, which is really interesting because it is different from if you look back in the literature from a long time ago. We are seeing the world in a way that's sort of grounded in this time and place. And the way we're going to analyse the data is using a grounded approach. What that means is that despite us all having strong views about how maths and stats should be taught, we're not going to analyse the data via hypotheses. We're not going to say, does it say this, does it support that? We're going to go, it's called a grounded approach, which means you let the data speak for itself and you see what it says in its own right. And so that'll turn out, no doubt, new and interesting things that we wouldn't have said otherwise. The other half of the project is capturing the student voice on this. And this has come out of some work done by Paola Iannone. Is that about right, Leanne? Iannone? You know, no. All right. And Adrian Simpson, a little bit over a decade ago, they did a really interesting body of work. They did a literature review on work capturing the student voice, on whether students liked exams or not, because overwhelmingly the students hated exams. What they found was there was not a single paper in there that had asked maths students. They almost all asked students from arts disciplines. There were a couple in there that asked some engineering students. There was a couple that asked physics students, but no one had talked to maths students. And so they did some studies to rectify this, and they wrote a suite of really solid papers about it. In case you're curious, the big part of what they did, they asked a bunch of social science students how they like to be assessed, and they asked a bunch of maths students how they like to be assessed. Social science students says, we hate exams, we love take-home essays. And maths students said, we love exams, we think they're the most appropriate thing for us. It's a sort of short and simplistic summary. So we were interested in reproducing that work sort of in the Australian context and post-COVID, and just see what happened. You know, what do students think about the way they're assessed? And while we're asking about teaching, how do they find the way they're taught in maths compared to the way they're taught in some of their other subjects? We didn't know. So this is where we're at so far. In terms of students, we've interviewed 9 engineers from Western Sydney, and they were a random selection. The way we tried to get them was we got the lecturers to advertise this study in class, and exactly no one responded. So I grabbed on, and we went and lurked outside their tute rooms and jumped on them as they came out until someone said yes. That's right. That's exactly it. Okay. For the maths students, we've done 2, and they were both volunteers. They did both respond to lecture request. We'd like to get a few more maths students from Western, and according to our ethics, we're supposed to do 10 students from UNSW as well. And Jim's got that lined up to happen soon with law. In terms of educators, the initial plan was for people to fill out a survey, and if they had more to say, then they could tick the yes, I want to talk to you box at the end of the survey, and then we'd interview them. But everybody who did the survey ticked the yes, I've got more to say box, and wanted to talk to us anyway. And so we've kind of ended up just moving straight into interviewing people, which seems to be working fine. The educators haven't been a random selection. We've been collecting them from places like this and Delta and other maths conferences. And also when we do talk to someone, they'll say, oh, look, you need to talk to such and such and such and such. And so that's where we're at. Essentially, we're happy to talk to anyone who wants to talk to us. It's not exclusive. So you're all invited. If you haven't been interviewed yet, we're happy to talk to you and get your views on these things. So that's how that's going. In terms of the educators we've got so far, you can see the demographics there. We're getting quite an interesting spread of people from quite a range of different institutions. One thing that quite a few people have asked is, does everyone from the same institution think the same way? And there is it's obvious that we influence each other. The people with whom we talk tend to have similar ideas, but on the other hand, if you look at UNSW, where we've got 9 people, polar opposites are coming out in interviews. So every possible range of views is represented by those people from there. So it's a bit of yes and a bit of no. And I guess it depends more maybe it depends more who you talk to than what institution you're from. Not sure, but that's where we're at so far. Now, the method we're going to be using to analyse the data is called thematic analysis, and it was developed by Braun and Clark, and they've published a number of papers on it, including the Dummies Guide for how to do this for total beginners, which may be why it's become such a popular approach to analysing qualitative analysis. The way they describe it is a 6-step approach. It's iterative within that. Step 1's familiarisation of this data. So in our case, we're recording the interviews, and then we're using Whisper AI to transcribe them. So the familiarisation step means listening to the interview, reading the transcript, and then summarising it. The second step is coding, and what that translates to is you get your transcript, and you read every single line, and beside every single line, you say what's going on in that line. You're meant to do it really succinctly in like a single word to summarize that, or 2 words. And the idea, and those 1 or 2 words are what's called the code. And the idea is you want a small finite set of codes that are repeated. And so there's a bit of iteration and a few go. It's like marking, you know, to work out what students are going to screw up, you've got to do a few papers and you go back and revisit those first ones in the light of that. It's sort of a bit like that. You read the first one and take a guess about some words and you see what sort of words are coming out, and then you go back and refine and get going. The codes do not have to be the participants' words. You're allowed to interpret. And I think for our stuff, that's going to be important. Once you've got all your codes, you kind of stick them up on a pin board or software or whatever, but you start looking at them, you look at linkages between them, where are the relationships between different codes, you group them together, and from that you develop a few broad themes. Now what's obvious from our data, from looking at it, is that there's 3 big meta themes coming out. One is what are students meant to get out of this, one is how should we be teaching them, and one is how should we be assessing it. These just happen to line up with the questions we're asking. This is good because I think it means we're asking the right questions, because they're the questions that are actually being answered. So I think we're on the money with how we've got that set up. Once you've got the themes, you refine and review them, and then you come up with fancy names for your themes, and then you report on it. So with those 3 big meta themes, as we look, we'll find other sub-themes within them that we can look at and talk about and think about. So I've been trying this for myself by hand to learn how it goes, because it's new for me. And at first I thought, well, yeah, I'm going to read it and I'll summarize it. Okay, I've got a great summary of what went on. That sounds fair enough. And I was a bit, so, well, why would you want to then sit down and write something about every line? Sounds like a lot of work for not much. But being a good Merryn, I actually did it. And what I found was that you get different results to when you summarize, which obviously I wasn't expecting. But when I thought about it, it makes sense, because when you summarize, you're saying, well, what's the main point of this? Or what's the main point of this page? But when you go through every line, you're saying, what's the point on this line? And you start capturing things that weren't the person's main point, but they're still points that they're making. And they might be making them in passing, but there's still things that they think and they thought were worth saying. And so you get a much richer data set by going through doing this. But it is slow and it takes a long time. So that's the traditional way of doing it, hand coding. Jim had the excellent idea that we might be able to use large language models to make this more efficient and do some of the work for us. So Gazum's joined us, and what she's going to be doing is developing a large language model that can do a perfect thematic analysis, where we can simply give it the transcripts, it will analyse them, code them, come up with the themes, and then write the papers for us. That's the ambit. So that's the ambit claim. If that was a complete disaster, we could do it all by hand and we would get there. But I think we're reasonably confident that we can at least do something in between. And when Gazum comes out with her model, that would be novel and really exciting in its own right. But what she was explaining earlier is that the literature has found that a sort of hybrid approach, where you hand code to get the themes, but then feed the transcripts and the codes into your model together, can get quite good outcomes. And so I think we're reasonably confident that we can get some kind of hybrid thing going. That would be interesting. It may well not end up saving us work, but in order of developing it, but then we'd know what we could do. And it would also mean that if we had that going, then there would be no real extra load in just throwing in more and more and more interviews, apart from the pleasure of talking with people for half an hour, which is fun. Okay, so we're only sort of halfway through this study at the moment, but I couldn't really talk about it without telling you something about where things are at. So in terms of the engineering students, you've all read the first line already. That doesn't mean we got nothing out of them, but the main points that were coming out was they all said, well, yeah, the way we're being taught and assessed is fine. You know, why are you asking? And they like being continuously assessed. They love their weekly quizzes. They like that for many reasons. And they all, well, not all of them, but many of them announced that they really like the maths support that they get. And so what I think about this is, well, first up, I think that they're probably, many of them, saying what they think we want to hear, despite being told that this is anonymous and we really want their genuine opinions and so on and so on. I suspect that they were just saying what they thought I wanted to hear. I mean, maybe maths support at Western Sydney is the, you know, the shining beacon of their existence while they're there, or maybe they were just saying it because they thought I'd like to hear it. I think probably the latter. It was clear that they haven't thought about teaching and assessment in maths, and this isn't a huge surprise. And they're just trying to survive their engineering degree. They're not sitting there spending their afternoons discussing how their teachers could do a better job. And so I think they just haven't thought about this. It's not really, you know, it's just not something that they care about thinking about. And a random selection might not be the best approach. We deliberately decided not to go with a random selection for educators because we weren't interested in the views of people who weren't interested in education. And possibly, you know, the same thing applies for students. If these students are not interested in these things and haven't thought about them, then we shouldn't expect to get great information out of them. The maths students' interviews were much better, and things that they said were that they liked active learning activities that they did. They liked having a variety of assessment types, and they liked the way they were taught. And again, I think that's probably the problem with using volunteers. If you, you know, if a lecturer says, you know, who'd like to participate in this study, who are you going to get? You're going to get the students who've got a lot out of the subject and want to give something back. And so we've got bias that way. So I don't know what the way to get good information out of students is. The best intel I've got out of students is when I've been tutoring them. I just have a chat with them in the classroom, and then they tell me all sorts of good stuff, but we can't sort of use that in a formal study. So if you know how to do this, I'm very interested. Yeah.
And when she says, okay, safe, that might be, that students are very frank and views in their maybe we can explore that. It's not part of the study and recruitment. They're volunteering a lot of information.
Yeah.
So, and you're right, I mean, so I'm wondering if you could just have some kind of where you're actually doing that maybe they have thought that you're asking but if you took some of the education people would you like to do better?
Yeah, that makes sense, Deb. Yeah, thank you. Worth trying, isn't it? I beg your pardon. Yes, we can. Okay, so Jim said, why don't we consider including the student teaching feedback survey data? And Deb said, why don't we give students short lists of alternative options and invite them to choose which ones they'd like better, rather than asking them more open-ended questions. Okay, so in terms of observations for educators, well, first up, there's heaps of data, it's not processed yet. So anything that I have to say, it's not even like, they're just random impressions that I've got so far, and nothing's going to look like that in the end. And the other part of that is we are still interviewing, and I know that some of you are in our interview queue, and whether you know it or not. And I don't want to mess with that. So on the next slide, I've got some things that are coming out of the data really clearly. so that you can see at least that our data looks sensible, and they're things that you probably won't want to argue with. So the first thing that's coming out is there's a very wide range of positions, but they're all carefully considered and justified and justifiable. So there's certainly no consensus about how things should be done, but every position is, really well thought out. Fairly obviously, what and how we teach is highly dependent on who we're teaching and what we're teaching them and why they need to learn it. No surprises there. There's lots of constraints on teaching and assessment coming up. Euphemistically, many people feel neglected by the university management. The senior subjects in general, people seem to be pretty... There's higher levels of happiness in teaching more senior subjects than teaching first-year subjects. There seems to be bigger issues with teaching first year. It's a more complicated environment to be living in. And things there include the cohort sizes, the heterogeneity of students, their underpreparedness, and their disengagement in some cases. In general, across the people we've interviewed, not universally, but active learning, collaboration between students, and communication skills are things that seem to be highly valued, as well as the maths. So where we're going from here is we'll finish the interview and do thematic analysis, but we've got this rich data set that we can actually do a whole lot more with. It'd be a shame just to do a single thing with it and then throw it away or something. So what we can do is, after we've let the data speak for itself, we can actually go back to it and ask it questions and see what it says. So go in with hypotheses and find out what it says. You can ask what you like of whatever you like, but there's only really value in asking things if someone cares what the answer is or if they're useful. And so I wanted to ask you, if you had this rich data set sitting in front of you with 40 odd expert educators' views on how to do things in different situations and why, what should students be learning? Why should they be learning that? How should we teach them? Why? And how should we assess them and why? What would you like to ask out of that? So some things have come up during interviews. Some examples are, how do you go about teaching a bunch of students who just don't want to know about your subject? That one's got asked. Things like, what sort of teaching assessment methods are scalable? I do these nice things with my third years, but I can't do them with my first years because I've got too many of them. Does anyone have any methods that scale? Or if we're just going to keep teaching students how to turn the handle on things, maths is going to die because computers and AI can do all of this. So what's the story we need to be telling students as we teach them so that maths stays relevant? There's some of the questions that people have asked. So, if you have questions in your head right now, I'm interested. If you think of questions sometime in the future, just let any of us know, and we're interested in knowing what sort of things would be useful to look at this data set in the light of. And that's everything I've got to say.